This computer has a little bit of an early time, so I've been starting all the classes a little bit early. My apology for that. So the real time now is 6:31, and I don't know if you can see my screen here, but it's 6:33 on mine. So I've been starting the class a little bit on the early side, so my apologies there. Somebody could have mentioned that, but I tried changing the time here, and I'm not sure I'm allowed to. This computer I got from Clark College, and it's not allowing me to change the time, so I'll just try to remember I'm a little bit fast. All right, are there any questions? If not, let's go ahead and take a look at what we're going to be doing. Today we're going to be doing Lab Module 3, Microscope Basics. And please read the textbook Chapter 3 through the end of the section on compound light microscopes before you do this lab. You should also do that reading before Lab 4. Let me mention that if you haven't turned in a project for your infectious disease project, then please get that into me. I've only got a handful of students who have requested an infectious disease. You need to clear it with me, because if you do a disease that I don't allow and you don't clear it with me, you're really going to be marked down. I want you to clear it to me so that everyone's doing a different disease. It is true that when we're talking about things like pneumonia, there's many different organisms that can cause pneumonia. And if you ask for pneumonia in some disease like that, I'll tell you, you can't do it on that project, but you can find one species that causes pneumonia and then do your report on that one species that causes pneumonia. And the reason why that one comes to Bell is one of the students did request pneumonia. And I told them, no, you can't do it on that project, but you can choose one microbe that causes pneumonia and do the project on that. All right, any questions about what we're doing? If not, let's move on to Lab Module 3, which you can get the Lab Module 3 by clicking here and the worksheet by clicking here. I'm going to bring up my version because I've got it highlighted for what I want to talk about. Lab Module 3. I've already told you about reading the textbook, Chapter 3, the primary learning objectives. You're not physically going to be using a microscope in this lab. However, upon completing the lab, you should be able to locate and name the parts of a compound microscope along with describing their functions. You should be able to calculate the total magnification for each objective that you use, know the guidelines for focusing specimens with different objectives. There's 4 different objectives you need to know about: the scanning objective, the low power objective, the high power objective, and the oil immersion objective. And I don't usually call them that. I will call the scanning objective the 4x objective, the low power the 10x objective, the high power the 40x objective, and the oil immersion the 100x objective. Those are the terms I use just to be a little bit clear, and realize when you use low power and high power, that low power isn't the lowest and high power isn't the highest. Please estimate or be able to estimate the size of a specimen when seen at different magnification powers. In fact, that'll be one of your questions I'm going to tell you. And this is your objective lens, this is your field that you can view, and this is the specimen in the field of view. Give me the estimate of the size. Understand the rules for proper microscope care. You're not really going to be working with a microscope, but you do need to know the rules for taking care of the microscope and be able to define the terms associated with the microscope. Any question about any of that? If not, memorize the name and the function of these parts 1, the ocular lenses, 2, the objective lenses, 3, the stage, 4, the stage clip, 5 isn't being shown. Let me scroll down. Let me move that over there. 5 is the stage control knob for moving the stage around, or I should say the stage clip around. 6, the iris diaphragm level. 7, I think that's the condenser. Yep. I wasn't sure what that's pointing at, if that's the iris diaphragm or the condenser, just because they're together. 8 is the coarse focusing knob. 9, the fine focusing knob. 10, the on and off switch for turning on the lamp. 11, the rheostat for adjusting how bright the lamp is showing. And 12, the lamp itself. Also called the illuminator. The light intensity dial, I call it the rheostat. You must memorize this table for the names of the objective lenses, the power, magnification power of the objective lenses, the total magnification. And the total magnification is the magnification of the objective lens, 4x, times the magnification of the ocular lens, which is 10x for all of our microscopes. So the total magnification is 40x for our scopes. Generally, the ocular lens has a 10x magnification for all of the microscopes at Clark College that I'm aware of, certainly in the microbiology lab. They have 10x magnification, but you can have a different magnification for the ocular lens, and some microscopes will go up to an ocular magnification of 20x. The depth of field, that's how much of an object you can see in the objective lens. For the 4x objective lens, the depth of field is deep, so that for a large cell, you could see all of the cell. I'm talking about a large cell, not like a skin cell or something small like a bacteria cell. A large cell, maybe like a human egg cell. You can see all of the cell, the top of the cell and the bottom of the cell, in the under the microscope with the 4x lens. As you go up in power, the 10x lens has less depth of field, so maybe you can see half of the cell in the depth of field that you're viewing. With the high power lens, it's even smaller, so maybe you can see a fourth or maybe a tenth of the cell in the depth of field. And then the oil immersion lens is a very narrow depth of field. So you're seeing essentially one plane of the cell in the field of view. Any question about that? The important thing to remember is that you go up in power with the objective lens. The depth of field is reduced. Any question about that? The field of view is similar. The field of view is the field that you can view around what you're observing. And the largest field of view is with the 4x objective lens. As you increase the objective lens, you'll get a smaller field of view each time you increase the objective lens. So you have the largest field of view with the 4x lens, a moderate field of view with the 10x lens, a small field of view with the 40x lens, and then a very small pinprick field of view with the oil immersion lens. And then some comments. The 4X lens is the easiest to use because it has the deepest depth of field and the largest field of view. And then the oil immersion 100X objective lens is the hardest to use because it has the narrowest depth of field and the smallest field of view. Any question about that? If there's no questions, let's move on. When you view an image under the microscope, not only will it be magnified, but it'll also be inverted and reversed. So when you're looking at the letter E under a microscope, it'll look like this under the lens. The iris diaphragm is an important part of the microscope, which can be opened up or closed down to allow more or less light through the stage. More importantly, the iris diaphragm affects the contrast of the specimen against the background of the slide. So, generally speaking, when you start with the microscope, you have the iris diaphragm open, and then as you go up in objective lens, you start closing it down to increase the contrast of the specimen against the background. If you don't close down the iris diaphragm, then the cell that you're looking at will get less and less contrast, so that eventually it'll just blur into the background and you won't be able to see it from the background. The iris diaphragm, when you open it up, allows more light to come in, but generally that's not used, except maybe under low power you can open the iris diaphragm to get more light. Generally, to get more light, you turn up the rheostat, because as you go up in power with the lenses, moving from one objective lens to another, you need to close down the iris diaphragm, which lets in less and less light, and so you need to turn up the rheostat to get more light as you're shutting down the iris diaphragm. All right, any questions about that? Some tips for focusing. When you first use the microscope, start with the 4X lens in place. Use the 4X lens because it's the easiest objective to work with. It'll give you the biggest depth of field and the largest field of view. Obviously, turn on the light, plug it in, all that stuff. When you're focusing for the first time, use the coarse focus with the 4X lens to bring the stage up, to bring the object into focus. After you have it in focus or close focus, then use the fine focusing knob to adjust the focus perfectly. Once you have the focus adjusted perfectly with the fine focus knob, do not use the coarse focus knob. And generally, you don't use the coarse focusing knob ever after this point. Only use the coarse focus knob when you're working with the 4X objective in place. All other objectives should only use the fine focusing knob. Move your object that you're viewing into the center of your field of view, and then go up to the next higher objective lens. The reason for moving the object into your center of your field of view, let me get this over here a little bit, is because if the object is over on the corner here, and you have it in the first field of view, and then you go up in your objective lens the field of view is much reduced, and now that object is no longer in the field of view. You won't be able to see it. So move the object you want to look at, I'll make it my head because I can move it, into the center of your field of view, and then move up to the next objective lens. The lenses are parafocal. That means that when you switch from one objective lens to another, the object should be in focus, at least rough focus, and then use the fine focus to bring the object into perfect focus for that objective lens. Move the object once again into the center of the field of view, fine focus it if you need to, and then go up or rotate the objective lens to the next higher objective lens. So repeat step 9 whenever you switch from one objective to the next higher powered objective lens. When you switch to the oil immersion lens, the 100x lens, you need to add a drop of oil. And that's because that lens really doesn't work any better than the 40x lens unless you add the oil. Oil has the same refractive index as glass and allows more light to be gathered by the lens. This greatly increases the resolution or the clarity of the image. Whenever you use oil, remember you have to clean the oil from the objective with lens paper. Only use lens paper to remove oil from the lenses. Or if you need to clean the lenses by anything other than oil, only use lens paper. Other paper has wood fibers in it which will scratch the lenses. So only use lens paper to clean the lenses, because lens paper has the wood fibers removed from the paper and they will not scratch the lenses. Any question about that? You can read about the troubleshooting for your activities. Online students are not going to actually be performing anything with a microscope because you can't handle a microscope unless you have one at your home yourself. But the table below is already being filled in for you. But you are expected to know the information contained in this table and how to use the formula in point 5 below. Let's move to point 5 and show you the table. So you need to know this table of the objective lens, their magnification for each objective lens, the diameter of the field of view under that lens, how much you can see, and you only need to know it in either millimeters or micrometers. You don't need to memorize both as long as you can convert from one to the other. And it's pretty easy to convert because a micrometer is 1,000 times a millimeters. So it's just this number here times 1,000. All right? You know, I don't really ever test you on the formula in number 5, but you should know that the field of view in millimeters of an objective lens in, like 4x, is equal to the diameter of the field of view, which for 4x will be 4.5, of the 4x objective lens, times the magnification of the scanning objective, that's the 4x lens, times the magnification of the objective lens. So for 4x, that'd be 4x over 4x, or 1 over 1. So the diameter of the field of view is 4.5 times 1, or 4.5. But you can do that for the next lens, the 10x lens, the diameter of the field of view. The 4x lens is 4.5 times the magnification, which is 10x. Oh, excuse me, no, it's 4x, divide by the magnification of the objective lens, which is the 10x. So divide by 4/10, and then you get 1.8 millimeters. Any question about any of that? Why is it important to know the diameter, the field of view for the different objective lens? Because when you see something under the microscope with that lens, you can get an estimate of its size. Like this one is, well, let's see, about 3/4, maybe 2/3 the length of the screen, and maybe 1/4 the width of the screen. So you can get an estimate of the size for what you're observing. As I stated, you're not actually going to perform any of these activities, but you will be doing a virtual exercise of the activity to complete the exercises. We expect you to know and understand the material in these exercises. So that goes through what you would be doing if you were actually doing in the lab. Activity 3, making a wet mount. This one you can ignore. You're not going to be tested on this procedure, and online students aren't going to perform it, obviously. All right, you should know about microscope storage protocol, how to properly store microscopes. You're not going to be handling real microscopes, but you are expected to know how to correctly store a microscope. So you can read through that. This note isn't important for you guys. You should know the microscope terms. And then work through the laboratory exercise. We have videos for you to work with and a virtual microscope lab, which this microscope lab that you go through, it's pretty slow to download and it's slow to run the program. So give it time to both download and then time for it to run. Like when you click on something, it doesn't immediately happen, especially if you have a slow internet connection. You need to practice naming the parts of the microscope, and I think this is a game for doing that, yes. And then fill out the answers for the questions. Don't fill it out here. Oh, I got it changed anyways, but remember to come here and fill out the worksheet and then submit the answers in the worksheet. All right, any questions about what you're doing? Any questions about anything? All right. Go ahead and get started.